A very warm welcome to OXXPUN, the technical magazine with Wolfgang Rudolph. Hello and welcome everyone. I have chosen a theme today I want to talk about, what you can't see and can only measure it using our technique. And it is about radio waves. Well, radio waves isn't exactly the theme, but radio waves are all around us every day. If it is the mobile telephone, what we walk around with, where radio masts stand all over, and more stand around, and the cells are getting smaller. Or if it is a radio, what we have at home for years now, or if it is our wireless router at home, or other things. Radio devices are normal nowadays, they are everywhere, but there's much more radio waves from which you probably don't know. Interference. Lots and lots of devices cause radio interference. That means they radiate waves out, and you cannot see these waves. They are useless for us. They are interference waves. Okay, there are laws which say how strong these should be, but who controls it? If we are lucky, the law enforcer, normally the manufacturer, does it and says, "Hi, I'm the good one." You have to believe it. There are always black sheep. So this radio story, what it is all in it, I'll just show you. In a normal socket, we have normally no problem. But we have here 4 USB connections fitted. That means out of the 230 volt mains voltage, it is down-regulated to 5 volts. Through switches, and these switches hack the electricity, and through this interference is caused in a wide frequency region. A socket without these causes in the norm no interference. All these between sockets, what we have also have a main supply in low frequency region, and when they are switched on, they are connected over radio waves with some sort of switchboard or computer over Bluetooth or whatever. And that is a radio piece. Oh, here is something else, a charger for battery packs. We have more and more battery packs that cause interferences as well. And if you believe it or not, radio bells or emergency buttons cause a wide spectrum of interferences. So now you can say, he can tell me a lot of things. I do that too. Look here, a light bulb. And modern LED lights have got better. But here we have an example. It is catastrophic. I'll just show it to you. That here is an amp-period measuring instrument. Let's see how the camera can see it at its best. Maybe so. Now I'll turn the light on attention. So, did you see the needle bang to the end? There's nothing. It doesn't just make light, but a high emission comes out too. Yes, okay, you can say we are still alive. What can happen? That is the problem. There are people who are very sensitive to that, from such emissions. I can't say why I'm okay with them. I live years with radio devices and other things, and nothing has happened to me. But other people have problems with it. And every person is his own chemical factory. You can't say by the one is the same as the other. One has a problem, the other not. We can't see all of that, but I can show you from my little camera, which is stood here. It makes a picture in high frequency, and put it into a very old TV, and even with a walkie-talkie, see what happens. Now when I send you, can see there, that is what it looks like. And when you imagine all around us such waves as picture interferences are, and when the camera could identify these waves, you would not even see me. As of now, there is nothing to see, when if I go close, it is all gone. That is what the world really looks like. But with our eyes, we only see a certain frequency region, our red, blue, green, and a little on the edge, and not more. And this bulb, no, it isn't a bulb, the LED bulb interferes like the walkie-talkie. I'll place my radio in front of it. It's a bit daft. I'll hold it in my hand. As you can see, it is in UKW region, and switch the bulb on. As you can hear, it causes interference. Other frequency areas outside of our radio area, the interferences are stronger. They are very wide, so now we have that problem. We don't really want that from one interference, need energy. It has to be put in that it comes back out. And if we don't do any interference, the system needs less energy. Apart from that such interferences interfere other devices, maybe when you lay your mobile onto an analog amplifier, you can hear now and then the interference sounds the pulse that here exists. So now you have to in some sort of way for us make recognizable. I can show you how that works in the simplest way. Look here. I have a microampere meter, and in simplest form I have soldered a diode onto it, and it closes a half wave, and the connection aerials of the diode I use as an aerial. And now when I push the send button on my walkie-talkie, you can see something is shown. That means something is being broadcasted and is rectified and shown. With a little more outlay, not so primitive, I've built something here, as you can see here in the middle, a porcelain piece it looks like. That is a diode what goes up to around 3 gigahertz. That means I can measure the leak emission from my microwave and see. And look here, when I turn my walkie-talkie on, it is shown too. That means something really happens. The device what I showed you at the beginning, it has a built-in amplifier, and because of this it takes much more lower voltages to account and shows them. I can go away as far as I want to, it goes to the top. So we have in our technical world all around us with a lot of emissions to do. Not only the high frequency, but also the lower frequencies. Every transformer here is a power adapter. It creates a magnetic field, and this magnetic field expands. You might know that from your physics class. You took file shavings and a piece of wood or paper or cardboard and held a magnet underneath, and you could see the magnetic field lines. That is how you can imagine this there is a transformer, and it generates them as well. By modern devices you have switching power supplies, much more vicious. Every power line in your house emits an electromagnetic field. You can measure it. We have the power line search devices, they react to metal to see if voltage flows, and all of these things. If you try to be conscious of what we have day in day, with our electro stuff everywhere, that is scary. There are special devices with which you can, with such magnets, I brought one with me, the magnetic field measure, energized field measure. The high frequency voltage, what we have everywhere in the air around us, measure. And we can naturally the magnetic fields measure. A lot of things that make us aware what happens around us. If you want to look if your devices at home are okay, important like I said with the microwave, that no emissions leak, they can also be dangerous for humans. They don't just heat up the pig, the little piece what is inside of it, but our fingers are such when we get too close to the place where it is leaking, and we should have a look at that. I have chosen 3 devices to look at, and I would like to show them one after the other. So I have the PCE-MFM 2400 here. I've had a look at it. This is what it looks like. Handy and lays good in your hand. It has a large display. You can turn on the backlighting. That makes a difference. That is also interesting. It's a magnetic field measuring device. That means I can measure magnetic fields. That is not only them that are produced from magnets. These magnetic waves, what we know of, what you may know from school, but on many electrical or electronic devices, a printer for example. It has the craft joints to connect the fluid connection for the motor and another piece that has to be driven, the Wallstrom and so forth. And it is switched from the operating system. Sometimes they don't switch and you don't know why. And then this magnetic field you can measure relays or similar things measure. There are relays that have maybe got stuck like some people too. And these magnetic fields are there but it doesn't switch. And such things you can measure with such a device. I'll show you what we can do with this. Here the probe is connected. I have to open the probe. So, and here we have something very special. Here at the front, on the tip there, is a Hall generator. It is written Hall. It is named after its inventor. And this Hall generator is a semiconductor, which in a magnetic field, its characteristics, its electrical characteristics changes. And you can measure this. That is the principle. This device is available in 2 different versions. For one is the transverse version, that is this one, and one with the axial version aligned. I can push it against something and measure the axial direction. Now look here, I have a small magnetic cube, and when we get that together onto one picture, so I'll go closer to this magnet, and you can see the magnetic field goes up. And now an N is displayed. The pole of the magnetic is simultaneously dictated. I'll turn the probe around and now S is there, like north and south, or plus and minus, whatever. So you can see a magnet, so if I come from the side it doesn't work. I need a different probe for this. Here I get any sort of values, which are stray values. So magnetic field measuring device. So and to protect it we put the cover back on. And it measures in the areas of 24 Gauss, up to 24 Gauss. An old inventor, a Swiss inventor naturally, he had the research magnetic fields, and so normally his name is written with SZ, but for international reasons with double S. Today we calculate with a SE formula. It was determined in 61, I think, as Tesla. It has nothing to do with the cars, but Tesla was a great scientist. And this magnetic flux density was named after him. You can convert this, but they are different, but it is important that there are different size systems. That means I can say 24 Gauss are 2.4 millitesla. I can't say it is equal because there are different size systems. Maybe a daft example. Men and women's clothes, you can't say the clothes size 45 for a man when it exists is the same as that for a woman. There are different size systems. One is Gauss, the other is Tesla. But you can switch the device over depending on which area I am working in. I can work in Gauss or Tesla, in milli-Gauss or micro-Tesla. A device which in a technique in many areas comes to use, where you can look, is a magnetic there or not? Is it strong enough? Is my device working or not? Or do I have to search for the fault somewhere else? A handy nice device is powered with a 9-volt battery, the MFM 2400 from PCE Instruments. I have here the EMF 823 from PCE. It is an electro smog meter. With this I can measure electronic smog, what is all around us, in a frequency area of 30 to 300 Hz. In this area at home we have 50 Hz, in some countries 60 Hz. Those fields which are there I can measure easily with this device. So how does it work? As you see, there are a few buttons. Switch on button is clear. Range button is the area switching we come that in a moment. Record button, with this I can record and save data and later minimum and maximum read. The hold button, if I have to measure something around 3 corners and I can't see the display, I just push the hold button and then I have this measured value in display and then further measure. Units is again the story from we measure normally from the SG method, or what is given here it is Tesla. In this case micro Tesla. And I can switch over to Gauss. And what do we have here at the bottom? Backlight. The backlighting I can show you. It is so when in daylight. And so it is under the sofa when you call around in the cellar. And as I can show, that is very good. So what do we do with it? Look, I have a power strip laid here. I'll put the device next to it. As long as I move it, cut field lines, it shows something, and here in the studio we have plenty of rubbish flying around. I'll just show you when it calms down. The power strip is turned on at the moment. I'll just turn it off. There is an impulse because fields are built up or down. I'll turn it back on. It is clear we have so much interference here, but it is minimal. Nothing large changes for the moment. And then it goes back. But it is from 20 microtesla to 2400 microtesla. 2.4 millitesla is the measuring area of this device. So now I have plugged in an old power adapter. Moment it was turned off. And it measures all around us what is in the air. I'll just switch it back on. As you can see, it goes on to the overflow. Just see that I can get my range button and it has gone into the next area. So now you can see that I can measure this. Turn it off. And back on. So that is a measuring device which I can, the normal rubbish what is around us and we cannot see, measure. There are a lot of people who are electrosensitive I can't imagine if I don't know how it feels. Luckily, I don't belong to this group. They can find out in their house which device makes the most electrical rubbish, makes electrical fields, so that is what it looks like. The PCE-EMF 823, which from 20 microtesla to 2.4 millitesla measures can, and is switchable in the display to Gauss. So now I have a small but nice device here, the EMF Tester from PCE. That is a device that can do a lot. It combines as well as a high frequency device depending on what high frequency waves or what source are around, as well as it can show me electrical fields like power lines, magnetic fields and so forth. And it can show magnetic fields as good as I'll just show you. I have my little magnetic cube here, and I'll just put it back on the back here, and you can see in the top section it shows me in which direction a magnetic field is in XYZ presentation. When I turn the magnet around in a different direction, you can see that it has changed. And now I've turned it again. Also I can determine the XYZ direction. And because it is P-pin, is because it has fast set values. And as soon as they are overstepped, it gives an acoustic signal and says here's something wrong. You can turn that off though. So let us take this old transformer, a very old adapter. There's a transformer in it which shows in the middle of the display. The middle display stands at 108. Now when I turn on the power strip and with that the adapter, then you can see the value goes extremely high. To 311, 312, and when I turn it back off, it goes back down. And in the top area you could see that even the magnetic field from this transformer is seen. So now we have the bottom area. For this I will stand it back up, it is easier to see. And I take a handheld radio and go to 2 meters away. I can do that and send a carrier. You can see a lot of rubbish in the bottom part. Here in the studio, because of the microphones, the lamps are radio controlled and so forth. A lot of things. Now when I press the send button, it takes naturally a moment. So now it has its measuring interval gone by. Left next to the bottom area you can see there is a small graphic display and it shows me the last 20 measured values, and then it has gone to the limit. When I leave go, the value goes down straight away. You can see this in the graphic. There's always a delay, but until the device has the data ready. So there are 3 different measuring systems: magnetic field measurement in the 3-axle XYZ direction. With this we can from 20 microtesla up to 200 microtesla determine, but also the direction to determine. I can in the next area 50 volt per meter to 2000 volt per meter, what we measured on the transformer. By 50 respective 60 Hz determine. And that is a lot. 2000 volt per meter, and to comes in a further area 30 millivolt to 11 volt per meter. From 30 Hz to 3.5 gigahertz determine can. That means if you have a Wi-Fi router at home and it works with a 2.4 gigahertz, you can test this field with this device. see where it is strong, where it is weak. You could then the position change. You can determine also, it happened to me, if any switch sockets are going crazy and send something into the Wi-Fi, always even that you can search for and find and throw away. But in the special waste, all the technique what we have today is special waste. I have the possibility, a lot of values to change. I can set millivolt per meter or volt per millimeter, microwatt per square centimeter, milliwatt per square meter or milliamp per meter. Those are the different areas that I can set. The system shows me the corresponding values in these dimensions what I have chosen. A nice universal device. It disappears nearly in your hand, and can be used universally. Three devices to measure from that what we do not see. What is in our environment, what is all around us, even in our vehicles, for example, also in the child's room. The first device from PCE, the MFM 2400, a device with a large display, with backlighting, and an external magnetic field probe. With that I can determine, and with this probe here, it belongs to the 2400 transferable onto the magnetic field source and determine the strength. It is also available as 2400 plus. There's a different probe with it. It is radial, and you have to go to the magnetic field also with it. In every usage area you can choose the right device. The second device was I have here, that is the PCE-EMF 823, an electronic smoke measuring device. It doesn't measure magnetic fields, but this magnetic fog what is all around us. Electrical fields, from power lines, transformers, from devices, from machines, from hoovers, from all devices which have something to do with magnetic fields. And very electrical cable builds up when electricity flows through it, around it a magnetic field. And that you can also measure and determine. In the area from 30 to 300 Hertz can there to be measured fields be, and a strength from 20 microtesla to 2400 microtesla, also 2.4 microtesla have. And the last device, that is the PCE-EMF 40, a multi-measuring device. I have to say, I nearly said multimeter, but that is something else. It has three different measuring functions. For one, I can determine magnetic fields. An X, Y, Z factor of the magnetic field is shown. I can see in which direction the magnetic field expands or where it comes from, depending how I want to measure it. It works from 20 microtesla to 200 microtesla. That is enough to determine magnetic fields anyway. In the middle area, it has a different function. I can determine electrical fields like the device before, then from electric flowing lines generated. There can be coils, there can be motors, there can be transformers, and so forth. Everything what is at home and always around us, I can determine with this. In the area of 50 volt per meter to 2000 volt per meter, by 50 to 60 Hertz. So, and I also have the possibility from 30 millivolt to 11 volt per meter, or from 30 millivolt per meter to 11 volt per meter, from 50 megahertz to 3.5 megahertz, with to measure and to determine. To the numeral display, there is also a graphic display, where the last 20 measured values are shown. For a quick look, I can switch from millivolt per meter, volt per millimeter, microwatt per square centimeter, milliwatt per square centimeter, and milliamp per meter. A measuring park what you would wish at home when you are electrosensitive, when you look for any source of interference. Here with the last device, I can in the area of Wi-Fi 2.4 GHz see where the field strength is and when my route is enough, where it is not enough, where I should put it that its field is good. So nice device. Well, it's been fun, and bye.
Discover and order the latest measuring and test equipment now on www.pce-instruments.com.